In this video, we're going to discuss how to find the domain and range of a function from its graph. So we discussed in 2.1 what the domain and range of relations are. And again, a function is just a special type of relation. So the same definitions would apply. The domain is the set of inputs and the range is the set of outputs. Now, when we had a finite number of inputs or a finite number of outputs, we just used set notation with braces, and we listed the values of the domain and range with commas in between. When we have a function with infinitely many points, we usually can't physically list out all the values in the domain and range, so we usually use interval notation to indicate the domain and range. So when we're looking at the inputs that show up on the graph so that we can find our domain, it helps to keep in mind that the inputs fall along the horizontal axis, which is usually labeled as the x-axis. So when we're looking at the domain, we're looking at which x values show up on the graph. So for example, the x value 0 is in the domain because there's a point with an x value of 0. The x value 5 is in the domain because there's a point on the graph with an x value of 5. If we keep following the graph forever to the left and forever to the right, eventually we can find a point with any x value. Even if we wanted to find an x value of 100, if we followed the line far enough to the right, we would find an x value of 100. If we want an x value of negative 10.2, we could eventually find one if we followed the graph to the left. So since the graph extends forever left and forever right, and there's no x values that are skipped along the way, the domain of this function is just all real numbers. So to signify that, we use this interval. So negative infinity symbolizes that the graph goes forever to the left, and positive infinity symbolizes that the graph goes forever to the right. Similarly, for the range is the outputs, which are on the y-axis. So if we follow the graph forever up and forever down, we can find a point with any y value that we want. So the graph extends forever up, forever down, doesn't skip any y values along the way. So the range is also all real numbers. So for the y direction, the negative infinity symbolizes that the graph goes forever down, and the positive infinity symbolizes that the graph goes forever up. Okay, let's look at the second function that's graphed here. So again, the domain is looking at the inputs, which is the horizontal direction. So we're looking at how far to the left does the graph go and how far to the right does the graph go. So we have arrows on this graph again. So this graph goes forever to the left, so toward negative infinity, and goes forever to the right, so toward positive infinity. And there aren't any x values that get skipped along the way. Every x value will show up at some point on this graph. So the domain for this one is also all real numbers. If we look at the range, the y values this time, we actually have a lowest y value on the graph. The lowest y value occurs right here. The graph doesn't go any farther down than that point, and that point was labeled 0, 1, so it has a y value of 1. So in other words, 1 is the lowest y value on this graph. We don't see a point, for example, with a y value of 0. We don't see any points that have negative y values. The lowest it goes is 1. So to symbolize that, 1 is going to be at the left end of our interval. And since we do have a point on the graph with a y value of 1, that number 1 is part of the range. So we have a square bracket at that end, signifying that the number 1 is part of the range. So that's the lowest the graph goes. Now let's check out how high the graph goes. If we start following the graph, if you kind of trace it with your fingers, it keeps going up, up, follows the arrows up forever, doesn't skip any y values along the way. So in other words, every y value that is greater than or equal to 1 is part of the range. So it goes forever up. So when we solved inequalities, you took inequality statements like this and translated them to interval notation. So that's a similar idea here. All right, so here we have another function. Let's look at the domain first. So it's the horizontal direction. If we start following the graph to the left, trace it with your finger there. Follow the graph to the left. It's just going to keep going forever left because of that arrow. Similarly, if you start tracing it toward the right, it keeps going forever to the right. And along the way, there aren't any x values that get skipped. So once again, the domain is all real numbers. So again, to signify that it goes forever left, we have negative infinity at the left end of our interval. And to signify that it goes forever right, we have positive infinity at the right end of the interval. All right, for the range, if we follow the graph down, last time we had a lowest y value, but this time we can just keep following the graph down forever because of those arrows. So there isn't a lowest y value, so the y values are heading down toward negative infinity. As we trace the graph up, we do find a highest y value. Right? The largest y value on this graph is 2. There aren't any y values larger than that on the graph. And again, the number 2 is part of the range because there's a point on the graph with a y value of 2. So that is included with the bracket. All right, one more here. So looking at the domain, how far left does the graph go? Well, the farthest left that the graph goes is this point right here. Right? We don't have any points on the graph any farther left than that, which means that the smallest x value on this graph is 3. For example, you don't have any x values of 1 or 0 or any negative ones. So 3 is the smallest value in our domain. And then from there, as we follow it to the right, the x values just keep increasing, and it's going to keep increasing forever to the right. So, and with positive infinity. So basically what we're saying here is the domain is all x values that are greater than or equal to 3. Okay, and then for the range, we look at how low the graph goes. The lowest the graph goes is that point right there. So the lowest y value is 0. We don't have any negative y values on this graph because it doesn't go below the x-axis. And 0 is part of the range since there is a point with a y value of 0. And then as we follow the graph up, it's going to keep increasing. This one increases more slowly than some of the other ones we've seen, but it does keep increasing forever as you follow the graph. So we're going up toward a y value of positive infinity.